Hello everyone. In this video we're going to go over the exam review 1 and the short answers. So first we're going to check some sinusoidal functions and we're going to get information on those sinusoidal functions. So if you check this here, what we always want to find out is things like what is the midline, what is the period, what is the amplitude, and a formula that might fit the graph. So this here is a very general formula. We have y equals d, which is the midline, plus a, which is the amplitude, and then we can say sine or cosine of bt, and this is the frequency or speed, and this is going to be determining the period, which is 2 pi over b. Okay, so with this information, there's a couple of things that we can find out. So first, the midline is going to be the middle between the maximum and the minimum. Here we have that this is between, we'll say here -5, -1 approximately, and 5. And you can see that the midline here is in 2. Why? Because the distance from 2 to 5 is going to be 3, and the distance from 2 to -1 is also going to be 3. So this point here is the midline. Also, you can check the midline from the graph, which is the point that kind of balances out what is up from what is down. So notice that this thing here should be equally distributed to these things here. So here the midline is 2. Now the amplitude is clearly the distance from the midline to the maximum or the minimum, which we also discussed this to be 3. So here the amplitude is 3. Now for the period, you can calculate using the distance between two of the same points. So for example here, you can check that this point is going to repeat itself here at 2. So you can take even the midpoint, or you can take this one. Here is a little bit more easy to calculate what this point is repeating. And so from that we can say, well, what happens here is 2 seems to be this amount, this distance that it takes to go from here to here. So period is 2, but if it's 2, this is equals to 2 pi over b, and so that means that b is going to be 2 pi over 2, and so b is pi. So with all that information, we can find out the formula for the graph. Y is equals 2 plus 3 sine of pi t. Okay. Now let's go with another case that is similar. So here we want to find a formula that fits this graph. So in this graph, we're going from what it looks to be -1 up to 3. Okay, so -1 to 3, that means that the midline is going to be here at 1. Since from 1 to 3 is the same distance that from 1 to -1. So finding the midline is one of the most important things that you do when you're trying to find this equation. So midline equals d equals 1. Now from that we can calculate the amplitude, because the amplitude is going to be the distance from the midline to the endpoint. So here the amplitude A is going to be 2, And once that we have that, then we can check the period. Notice the distance between two maximums is 4. So the period here is equals to 4. And with that, we can calculate B. How? Well, remember that the period is also 2 pi over B. So then we can calculate B as 2 pi over 4, or pi half. And so the equation of this will be y equals 1 plus 2 sine of pi half t, or pi half x, depending on whatever you want to use. All right, so question number 3 now is about having information that we can obtain for the circle. We have one end of a long spring is still in a room, and a weight is attached on the other end. So we have a situation where we have the ceiling, we have a spring, and we have a weight here, and so this is bouncing. This is bouncing up and down. So a certain point, this is just going here. In a certain point, it contracts this at this point. So these are the bouncing that happens with this weight. So the weight's pull down a little bit like here, and then it's let go, and the movement goes up and down, up and down. So we want to consider y be the position of the weight about its resting position. This means so values of y correspond to when the spring is being compressed, and negative value correspond to when it's stretched. So here we have negative values here, and we have positive values here. The position of the weight y can be modeled by a coordinate point moving in a counterclockwise circle. So we're going counterclockwise, so we're going in this direction. So first, which point represents the time when the weight is moving up and passing through his original resting position? So the original resting position, of course, is going to be the initial point where we start. So it's going to be here at A. Since this will be the initial point where the y is here. Remember, this is the y, which is the height, right? And so we're considering that behavior. This measures the height, and so this is all positive heights. Well, it goes up, and from 0 to a certain point, then it goes negative values, and then it returns to 0. Then, which point represents the time when the spring is stretched to the greatest length? Notice that this is a stretching down, so it's going to be on the negatives. The negatives are here, and so of course the maximum point of negative is going to be this point D. Now, this is just an application of this. Now, let's go and consider some points of the unit circle. So the points here of the unit circle are equal space. We want to consider this type of points because those are what we call special angles. Okay, so for example, A is 0 and 2 pi. 0 when we start, 2 pi when we complete full turn. And then we can divide this in pieces. So for example, this is pi, right? So this and this here is pi. And so because we're dividing this in 6 pieces, this is obviously going to be pi over 6. This is 2 pi over 6, which is pi over 3. This is 3 pi over 6, which is pi half. And then 4 pi over 6, which is 2 pi thirds. 5 pi over 3. And then 6 pi over, over 6. 6 pi over 6, which is 5. And so similarly, here we have 7 pi over 6, and 8 pi over 6, which is 4 pi over 3, similarly. Here we have 9 pi over 6, which is equivalent to 3 pi over 2. And this one here will be 5 pi over 3, so on and so forth. This will be 11 pi over 6. Okay, everything depends on how much we divided the circle. Now, which point corresponds to 5 pi over 3? Then we can check that this is k, which are the coordinates of the point L. So the point L is this one here, but the coordinates are given by cosine of 11 pi over 6, sine of 11 pi over 6. Remember, that's how coordinates x, y are calculated. Now, if you go with what is the meaning of this in special angles, this will be square root of 3 over 2 and minus 1/2. Now we want to know at which point we have a coordinate x of a square root of 3 over 2. And so this, for square root of 3 over 2, notice that we already have one of those. We know that it's going to be at L, right? So this here. And so this means that the reflection, because we're an x coordinate, it gotta be here, this one. So it's also going to be B. So this is B and L. Now we want to know y coordinate of minus 1/2. And so minus 1/2 is going to be negative, and minus 1/2 is going to be like here, just in the middle. So it's going to be H and L. Now we want to know what is the radian measure of the point H. And so this is 7 pi over 6, of course. So that's a little bit of getting back to the unit circle. Now for question number 5, we have the equation of a pendulum that is given as a sinusoidal function. The pendulum is swinging back and forth, and in the equation, L represents the length of the pendulum in meters, and theta 0 is the initial angle of the pendulum before its release. We want to write the equation of the pendulum that is 1 meter long and is released at the angle of pi over 8. So we're essentially here replacing the theta 0, which is pi over 8, and we're also replacing the L, which is 1. So it's just a simple matter of applying what we're reading. Now we want to find the period of this function in terms of pi. We have the speed, and so we know that the period is going to be 2 pi over the square root of 9.81, which is the B here. Okay. And that's it for this particular application. Now, question 6 in both A and B is a matter of making transformation between degrees and radians. So here we have radians, so we're going to transfer that to degrees. And here we have degrees, we're going to transform that to radians. To transform from degrees, from radians to degrees, we multiply by pi over 180. So we see here 11 pi over 6 multiplied by 180 over pi. This will be transforming this to degrees, sorry. Yeah, so you get to cancel the pi. And this 6 with this becomes 3, so this is 11 times 30. And so that will be 330 degrees. Same thing here, we have minus 7 pi over 3, and we multiply this by 100 over pi. Notice that the key is that the pi is canceled, and we get something in terms of degrees. Then this is minus 7 times 60, and this is minus 420 degrees. Here 11 pi over 12, and we multiply by 180 over pi. Again, the pi is canceled, and we get this multiplication here. We can simplify this by bits and pieces. So for example, I can divide by 6 everything. Divided by 6, everything, I get a 2 from here, and I'm gonna get a 30 here. And so now we can see a little bit better. This is gonna be a 330 divided by 2, and this is gonna be 165 degrees. Now on the changes of radians, of degrees to radians, same thing happens, but now we multiply by the opposite ratio. Now we want to keep the pi, and we want to lose the degrees. So we multiply by the inverse things. So pi over 180. So that's going to cancel out the degrees. And now we're going to have something that we can simplify, 130 over 85. If we simplify here, then we're going to get that this is 3 over 4 pi. Okay. Same thing with this 57. So 57 degrees times pi over 180. Again, you lose degrees. And this is 57 over 180 pi. And of course, you can divide again by 3. Divided by 3, this is 19. Divided by 3, this is 60. So this is 1960 pi. We have here minus 150. Same transformation. We keep the negative sign. We divide by 3 on both sides. And so this produces minus 50 minus 60 pi. We can eliminate the theorem. Minus 5 over 6 pi. And finally, 75 degrees. 75 by pi over 180. We lose the degrees, right? And then we have 75 that can be simplified by 3. It's going to be 25. And then this is 60. And then we can divide this by 5. So this will be 5. And this divided by 5 will be 12. And that's it. So this is the end of the short answers. Next, we're going to go with problems.